Hello everyone, my name is Yogendra Verma and I am currently doing my Masters in Chemistry from Vellore Institute of Technology, Vellore. I have completed my graduation in Bachelor's in Science and Bachelor's in Education from Regional Institute of Education, Mysore. Today I have selected the topic IIT JEE Chemistry, that to Chemical Kinetics for class 12 students, where we will be discussing about rate of the reaction and we will be understanding how to write the rate of the reaction. So the first point is why it is necessary for us as a JEE aspirant, necessary for us to look into this chemical kinetics topic. When you see the past trends in 2023 and 22, the JEE happened in different slots like 10 to 12 slots, and in each and every slot you could see at least one question from chemical kinetics chapter. So it is very important to study this chapter. And there is no excuse. If at all you want to get placed into some of the good IITs. So let's get into the topic without wasting much time. So before getting to the topic, I would like to ask you a few questions. So what do you remember right after you listen the word chemistry, or else you just go to Google, or whenever you get some free time, try typing chemistry in the Google. So when you go to the image section, it will show some colorful reactions everywhere. So whenever we think of chemistry, it is all about chemical reactions that happen, right? So for a chemical reaction, what is required? So what does chemist or scientist look for a chemical reaction to occur? So first of all, they look for thermodynamics of the reaction. What do we mean by thermodynamics? You might have all studied in your plus grade 11 what are thermodynamics. And right after thermodynamics, they look for chemical equilibrium of the reaction. So chemical equilibrium tells whether the reaction will carry in forward direction or the backward direction. And the third and most important one is the chemical kinetics of the reaction. Chemical kinetics tell us, seeing the word kinetics, what does come to your mind? Just give a thought about it. Kinetics means motion or else movement. And with respect to time, whenever we do something somewhere, we say that I have done this much amount of work in this much amount of time. So is there anything that you remember which can relate time and distance? So there is a concept, basic fundamental concept of physics, which establishes a relationship between distance and time, right? So that is, whatever you thought is really right. It is speed. Speed relates distance with time. So speed is given as distance per time taken. So kinetics is also referring us to some motion, some sort of motion, and speed is also some sort of motion. And kinetics also with respect to time only we will be calculating. And in speed also, it is with respect to time only, distance with respect to time. So kinetics is nothing but speed of the reaction. What is the pace of the reaction? How fast a reaction can occur, or how slow the reaction can occur. And if you ask me, is there any term in chemistry which specifically represents speed? Since speed is a physics concept, they are calling it as speed. If you ask me if there is any specific term for speed, yes, in chemistry also there is a specific term for speed, which we call it as rate. Rate of the reaction. Speed is nothing but rate of the reaction. So thermodynamics tells us whether the reaction is spontaneous or not, whether it will move, whether it is spontaneous or not. And chemical equilibrium tells us whether the reaction will take place backward or forward direction, and chemical kinetics tells us about the speed of the reaction, in how much time will the reaction takes place. Now let us correlate these three topics using some example, real life example. So I am sure that everyone knows about corrosion of iron or rusting of iron. I guess everyone knows this. You might experience this in your daily life as well. Wherever you see some iron material, it will get corroded on exposure to the moisture or air around it. So iron gets corroded. So here we have to try to establish these three topics like thermodynamics, chemical equilibrium and chemical kinetics for the rusting of iron. How can we relate? See, since del G, Gibbs, change in Gibbs free energy is negative or less than 0 for the corrosion or rusting of iron, it is a spontaneous process. What is spontaneous? Corrosion or rusting of iron is a spontaneous process because the iron has the tendency to undergo oxidation in the presence of moisture and air. So since del G is negative, the iron has tendency to move forward, to get oxidized and to form a Fe2O3 ferric oxide in. So it is like Fe in presence of oxygen will form Fe2O3. I am not considering about balancing the reaction, but this is to establish some concept. How does this reaction work? So now, since del G is negative, the process is taking place and it is spontaneous. We are establishing the fact that corrosion of iron is spontaneous. Now comes chemical equilibrium. What is chemical equilibrium? You might have learned about in your grade 11 that Lee-Chartier principle. What does it talk about? It talks about, first of all, it talks about change in concentration, change in pressure or change in temperature. How does the change in concentration, temperature and pressure will affect the rate of the, will affect the forward or backward direction of the reaction. See here, since iron is getting oxidized, it is moving in the forward direction. So chemical equilibrium tells us that the reaction, the corrosion will take place in the forward direction. So this reaction is spontaneous, and the second thing is it moves in the forward direction. Backward direction of this process is also possible, but under adding some reducing agents for the Fe2O3, it is possible. So we have also spoken about chemical equilibrium. Now comes the main topic, our main topic, chemical kinetics. What does chemical kinetics deals about? It deals about how fast the reaction or how slow the reaction will take place. So it talks about rate of the reaction. In case of rusting of iron, you might have all observed what is rusting of iron, right? So how much time will it take for the rusting of iron to happen? Can you tell me? It depends on the place where we live in. If we are in a place where the moisture is too much, the rusting of iron will happen in the span of days or weeks. But when you are at a place where the moisture is very less or humidity is very less, there the corrosion of iron or rusting of iron will take longer than usual. So this is what is determined by the chemical kinetics. Now I understand, now I believe that you all understood what is the significance of rate of the reaction or what is the significance of rate of the reaction. Now let us try to calculate rate of the reaction. Let us try to calculate rate of the reaction. Now we will try to relate speed with rate. Okay. So we all know that speed is nothing but distance per time. Distance per time taken. So since we all know that speed is nothing but rate. So I am just writing rate. Before getting into rate, let us understand we are taking 1 mole of reactant and it is giving us 1 mole of product. So we have to find out the rate of this reaction. Okay. So rate is nothing but rate of disappearance. You have to stress much attention on this word, disappearance. Disappearance of R is equals to, so now we have correlated speed with rate. Now we have to understand how we have to substitute distance. So here let us say we have 1 mole and right after the reaction starts, R gets consumed, so that we are writing it as rate of disappearance. R gets consumed, so it disappears eventually after some time. So we write rate of disappearance as R2 minus R1 by delta T. Delta T is nothing but change in time taken. Your time taken we have taken, so delta T is nothing but change in time taken, and we have to put a minus symbol here. I'll explain you soon why we have to put minus for rate of disappearance of the reaction. And let us also understand rate of appearance of reaction. Rate of appearance means the appearance of P, like that is product. So how do we write rate of appearance of P? We take it as P2 minus P1 divided by delta T, and there is no negative sign here, you have to note that. Why? We will understand these two topics using an example. Let us say we have 1 mole of R at time T is equals to 0, that is before the reaction starts, before the reaction time T is equals to 0. The concentration R1, I am representing, the square brackets is given to represent the concentration. The concentration of R1 is found to be 1 mole per liter. Simply we can write it as 1 molar concentration. And at the same time the concentration of P1, the concentration of P1 is nothing but concentration of product at time T is equals to 0. The concentration of P1 is 0 because at time T is equals to 0 the reaction has not started at all. But let us say we have kept the reaction and the reaction has started, and at time T is equal to T1 and T2, at time T is equals to 10 minutes, we are just saying that after 10 minutes the reaction has started. The concentration of R will be reduced because it is moving in the forward direction. We are considering that the reaction is moving in the forward direction, so it will get consumed. That's what we discussed, rate of disappearance of reactant. So it will get consumed, and the molarity of the concentration of R also gets decreased. It will become, let us say it has become 0.8 molars. Now since this has decreased and there is some product that has also formed, so concentration of product at time T is equals to 10 minutes, I am taking it as 0.2 molars. It is 0 molars. And now we will try to calculate the rate of the reaction. So here we will be calculating rate of disappearance of reaction, rate of appearance of the reaction. So rate of disappearance of reaction is nothing but R2 minus R1 divided by T2 minus T1. This is what we were representing as del T. T2 minus T1 is nothing but change in time, which we represent as del T. Here you can see that R2 is 0.8 molar and it gets subtracted by R1, which is 1 molar. So time taken for this reaction is T2 is 10 minutes minus T1 is at 0th minute. So here if you see 0.8 molar minus 1 molar is minus negative concentration of 0.2 molars. So negative concentration of 0.2 molars divided by 10 minutes. So is it possible to have negative concentration? Whenever you prepare something, you take some amount of some reactant R. Whenever you are preparing some solution, concentration can never be negative. Can you tell the speed? Can the speed be negative? Can you travel in minus 40 km per second per hour? It is definitely impossible. So in the same way, the rate concentration is also can never be negative. Rate or concentration can never be negative. So in order to rule it out, we are adding negative sign in front of it. So negative into negative becomes positive. So it is 0.2 molars per 10 minutes. Now let us try to calculate rate of appearance. I am just representing rate of appearance as RA and rate of disappearance of reactant as RD. So here we will be calculating rate of appearance. So it is given as P2, concentration of P2 minus concentration of P1 divided by T2 minus T1, which is otherwise represented as delta T. That you all know, you are very much familiar. Delta T is T2 minus T1. So concentration of P2 is 0.2 molars minus concentration of P1 is 0 molars. What is the time taken for this reaction to occur? It is 10 minutes. Changing time is 10 minutes minus 0 minutes. So it is nothing but 0.2 molar per 10 minutes. Here you can see, seeing this only you can understand what is the unit of rate. It is nothing but molar per minute. Now let us try to understand in detail the different units of the rate. So we will try to now understand different units of the rate. Rate is simply written as R. So rate of disappearance is negative of R2 minus R1 divided by delta T. This also can be written as P2 minus P1 of delta T. We are putting a negative sign here because rate or concentration can never be negative. You have to note that. Rate can never be negative. So now we will try to know the units. So rate is nothing but concentration per time. That is what now we have understood what is concentration and time. We have understood what is rate. So what is the units of concentration? It is moles. We represent concentration in molarity divided by time, which we represent as mole. For time we have different units. We represent it with seconds, minutes, hours, days, weeks, etc. So here we are just representing time with seconds. So the units of rate is molar per second. If we have learnt about what is the rate of the reaction and what is its significance, that is where do we use rate of reaction and how to calculate the rate of the reaction also, and we also gone through what are the units of the rate. So with this I want to conclude, and I want to thank Unacademy for giving me this opportunity. Thank you once again.